So what I've got here for you is a couple of questions relating to the inverse of a 2 by 2 matrix. What I want you to do is read the questions, pause the video, have a crack at them, and then come back and check your answers against what I'm going to present to you. Here you go. So just two big questions for you. First, I've got a couple of matrices I want you to find the inverse for. And then the second, I want you to use matrix multiplication to solve the system of equations that are given there. Now think about the key properties associated with matrices and their inverses, and hopefully that'll become a bit clearer to you. So pause the video and have a ping at those. So first question was find the inverse of these two matrices here. Now the first matrix up here, again, you've got to make sure you equate it and get your A, your B, your C and your D correct. So there's my A, my B, my C and my D. So from that, I could tell you that A is equal to 3, B is equal to -2, C is equal to -1, and D equals 2. First thing to check is my determinant, AD minus BC. So in this case, AD minus BC is 3 times 2, take away B, which is -2, times C, which is -1. So that's equal to 6 minus 2, which is 4. Great, that's non-zero. So that then means I can calculate the inverse. So if we labelled this matrix as A, I could say, fine, so the inverse of A is equal to 1 over this, so it's equal to 1/4, times the adjoint matrix of this. So in that case, that will become 2, 2, 1, 3. Swap this diagonal, change the signs. So there we go, I've got my inverse matrix there with the number outside, the 1/4. Take it in, what I'd end up getting is 1/2, 1/2, 1/4, and 3/4 there. So there you go, the inverse of that first matrix. Second matrix, I'm going to label this one as B this time, just for a change. And again, I'm going to do the exact same thing, equate it with the A, B, C, D, and figure out what my variables are. So my A, in this case, is going to be 2. My B is also 2. C is equal to -3, and D is equal to 3. Check the AD minus BC first. So check AD minus BC, and in doing that, I've got 2 times 3, take away 2, times -3. So I've got 6 minus 6, which is 6 plus 6. So that's equal to 12. So my determinant is non-zero, the matrix is non-singular and invertible, so I can just jump right in with both feet and do it. See, my inverse matrix B to the -1 is equal to 1 over the determinant, so 1 over 12, and then it's times the adjoint matrix, which can be given from the original matrix itself. So that's going to be given by 3, -2, 3, 2. So again, I could take the 1 over 12 inside if it really wanted me to. I'd have 3 over 12, so that's 1/4. Then I've minus 1/6. I'd then have 1/4 there, and I'd then have 1/6 down there. So again, it depends what format they ask for it, really, to be honest with you. You know, if they don't want it with a coefficient out front and a scalar multiple, take it in. Otherwise, you should be okay just where it was. The last one, use matrix multiplication to solve the system of equations given by here. Well, first thing to do is set the system of equations up in matrices. So I know 2x plus 3y and x minus y being equal to 1 and being equal to 3, I can set that up such that I've got a matrix given by 2, 3, 1, -1. And if I set the x and y up as a column matrix, x and y, if I was to use matrix multiplication on this, I'd have 2, 3 times xy, so I'd get my top line, and I'd have 1, -1 times the xy, and I'd get my bottom line. And I know that's going to be equal to a column matrix given by 1, 3. Now, using scalar multiplication, that's where the interesting part, matrix multiplication, that's where the interesting part comes into play. But what you have to remember is that A times the inverse of A is equal to an identity matrix given by 1, 0, 0, 1. Now, if I can get that, multiplying the x and y, I can then just read off the x from the top and the y from the bottom. So it'll just make my life a heck of a lot easier and make the system of equations a lot quicker to solve. So first things first, I want my inverse matrix. Now, I know that the matrix A is equal to 2, 3, 1, negative 1. So what that means is I can read off my variables A, B, C, and D, because I know that A is 2, B is 3, C is 1, D is negative 1. Again, check my determinant, AD minus BC. That's going to be 2 times negative 1. Take away 3 times 1. So that's negative 2, take away 3. So that's equal to negative 5. So I know AD minus BC is equal to negative 5. I know it's got an inverse, then it's just a case of writing it. So I've got A to the minus 1 equals negative 1 over 5 times, and then it's just the exact same as I would before. So I've got negative 1, negative 3, negative 1, 2. Swap your A and your D and invert the signs of the B and the C. So now that I've got my inverse here, what I can do is if I take this and I do my inverse A minus 1 times A times the xy, and I then do A minus 1 times the 1, 3, what I'll end up getting is my identity matrix here, I, and I'll end up getting a single matrix here, and then I should be able to just read off the solutions to my system. So what that means is in terms of the matrices themselves, I get negative 1 over 5 times my inverse, so negative 1, negative 3, negative 1, 2, times the original matrix, so 2, 3, 1, negative 1, and then that's then multiplying the xy matrix there, and I know that's then going to be equal to my inverse, negative a fifth, times the negative 1, negative 3, negative 1, 2, times the column matrix 1, 3. Now remember, it's kind of like algebra. I've multiplied this side by the inverse. I have to do the same to this side. What you do to one side, you have to do to the other. Now what that means is I know that this here, A to the minus 1 times A, that's going to give me my identity matrix. So what that means is that my left hand side is going to simplify to 1, 0, 0, 1, and my x and my y. And this right hand side here, I can use just generic matrix multiplication. So my rows and my columns there. I'll keep the negative a fifth outside just to make the calculations a bit easier and keep fractions out of it as much as I can. What I'll end up getting is negative 1 over 5 times negative 1 plus negative 9. And then negative 1 plus 6 there in the second one there. So negative 1 plus negative 9 is negative 10. Negative 1 plus 6 is 5. So that's then going to give me 2 and a negative 1. So what that means is because I'm multiplying the identity matrix by this will actually just go. It's essentially the same as multiplying this by 1. So I can then say that xy as a column matrix equals to negative 1. So from that, I could just read off that x is 2, y is equal to negative 1. I've solved my system of equations using matrix multiplication and the properties that I know involving the matrices and their inverses. The fact that the product of them, regardless of which way around they do it, for that single bit, so the matrix and its inverse, gives me the identity matrix itself. So there you go, new way to solve a system of equations. Something we have to get familiar with, particularly as we build it up into 3 dimensions, starting to look at inverses from there. A couple of quick easy examples for you. Nail this skill, we're laughing for the next step.